Dear students, in today's class we are going to learn what is contour integration and how to evaluate problems under contour integration. Definition: the initial and end point of any curve are coincide, then the curve is called closed curve. The integral over the closed curve is called contour integral or contour integration. What is contour integration? The integral over the closed curve is called contour integral or contour integration. Now in our syllabus we have 4 types of problems under contour integration. Among the 4 types, the first 3 types are the most important types. In university exam you can expect at least one 8 mark question from these 3 types. Sometimes they may ask direct 16 mark also. So before doing problems under contour integration, you must know what is Cauchy's residue theorem, because if you want to complete any problems under contour integration, you must use Cauchy's residue theorem. So without Cauchy's residue theorem, you cannot complete any problem under contour integration. Now what is Cauchy's residue theorem? Integral over C f of z dz, which is equal to 2 pi times sum of the residues of f of z at the poles. This already we discussed you last class itself. You did problems also based on Cauchy's residue theorem. Now I am going to explain you problems in each type. So before that, we'll see what is type 1, 2, 3. Now contour integral of first type. Integral 0 to 2 pi function of cos theta sin theta d theta is called contour integral of first type. Remember it, all type 1 problems under contour integration, integral 0 to 2 pi function of cos theta and sin theta d theta. Now f is a rational function in terms of cos theta and sin theta. So to evaluate the contour integral of first type problems, we need to consider an unit circle modulus of z equal to 1. In all type 1 problem, this C modulus of z equal to 1 means center 0, 0, radius 1 unit. You need to consider all type 1 problems. C is modulus of z equal to 1. Now consider the given integral as, suppose the given integral is 0 to 2 pi function of cos theta sin theta d theta, means this given, that can be written as integral over C f of z square plus 1 by 2 z comma z square minus 1 divided by 2 iz dz by iz. Now we got these values, this from that unit circle where C is modulus of z equal to 1. Modulus of z equal to 1 means z equal to e power I theta. How? If we take modulus of this, e power I theta is nothing but cos theta plus I sin theta. Taking modulus of this, cos square theta plus sin square theta, root of cos square theta plus sin square theta is nothing but 1. Root of 1 is equal to 1. So that's why z equal to e power I theta. From this only you got this. There is polar form of this modulus of z equal to 1 is nothing but e power I theta. Now z equal to this. If you differentiate this, what do you get? Differentiation of z is dz. Differentiation of e power I theta into I d theta. Now if you simplify this, you will get what is d theta in terms of dz. Similarly, now z equal to cos theta plus I sin theta and 1 by z. This conjugate is 1 by z cos theta minus I sin theta. Now from these two equations, if you add these two equations, that gives you z plus 1 by z, which is equal to 2 cos theta, implies cos theta is equal to z square plus 1 divided by 2z. Similarly, sin theta, if you subtract these two, that gives you z minus 1 by z, which is equal to I sin theta, implies sin theta is z square minus 1 divided by 2iz. So this is the way we got what is cos theta and what is sin theta and what is d theta. So these 3 values you may remember directly, or you can derive from these. Sometime they may give in the question, instead of cos theta, cos 2 theta, 3 theta. Like in that situation, cos 2 theta means you need to square this function. This is the basic assumption. From this, if you square on both sides, that gives you z square is equal to e power I 2 theta. If you expand this e power I 2 theta, cos 2 theta plus I sin 2 theta. So from that you can get what is cos 2 theta. I will explain you while doing problem. I will get that cos 2 theta in terms of z and sin 2 theta, whatever it is in terms of z, how to get. So why we are doing like this? If you want to apply Cauchy residue theorem, your function must be in the form of z, integral over C f of z dz. That is the concept statement of Cauchy's residue theorem. Now your given question is in the form of theta, cos theta and sin theta. So that's why we are considering all type 1 problem unit circle as the assumption. Based on this assumption, we are going to evaluate the given integral in the form of z. After that, apply Cauchy-Residue theorem, you will get answer. Okay, next we'll move to second type. Next, type 2. The integral of the form 0 minus infinity to plus infinity p of x divided by q of x dx, where q of x not equal to 0, is called contour integral of second type. What is second type of contour integral? Your limit must be minus infinity to plus infinity, and the integrand is quotient of two functions in the polynomial of x. And sometime instead of minus infinity to plus infinity, they may give 0 to infinity also. In that situation, you need to apply properties of definite integral and you need to convert minus infinity to plus infinity form. As I said to you, type 1, 0 instead of 0 to 2 pi, they may give 0 to pi also. Like in type 2, instead of minus infinity to plus infinity, 0 to infinity also they will give. The standard form of type 1 is 0 to 2 pi. The standard form of type 2 is minus infinity to plus infinity. But sometime they may give 0 to pi or 0 to infinity form. In that situation, you need to convert to standard form with help of properties of definite integral. Now, there is important condition between the degree of p of x and q of x. The degree of p of x, degree of q of x must greater than degree of p of x at least by 2. What is the condition? Degree of q of x greater than degree of p of x at least by 2 means the degree of p of x is 2 means the degree of q of x minimum 4, maybe 5, 6, 7, but here 2 means here at least 4 and beyond the 4 also. At least 4 means 4 plus rest of the values. Similarly, if a degree of p of x is 5 means, can you guess what is the degree of q of x? 5 plus 2, at least 5 plus 2. What is 5 plus 2? 7, 8, 9, whatever it is, but at least 7. So this is the condition in second type problems. Now, how to evaluate second type problems? In first type, we consider as unit circle, C as a unit circle, but in second type, the C is nothing but a simple closed curve consists of the real axis from minus r to plus r and the upper half of the semicircle gamma. Look this diagram here. What is C? C is nothing but the diameter, real axis diameter minus r to plus r, and this arc or arch gamma. It's semicircle. So C is nothing but this real axis from minus r to plus r and this arc gamma. So now look this. Consider the given integral as integral over c f of z dz. In all second type problems, you need to consider the given integral as integral over c f of z dz, where f of z is p of z divided by q of z. Means it's very simple. Instead of x, replace z. That's all. That is your f of z. Where c is simple closed curve consists of two parts. One is the diameter minus r to plus r and the upper half of semicircle gamma. Modulus of z equal to r. What is the meaning of this? It's a circle with the center 0, 0 and radius capital R. And this r you can take as much as large possible. This r you can take as much as large possible. Now, after this assumption, our integral over c f of z dz, which is equal to minus r to plus r. Already said to you, c consists of two parts. One is minus r to plus r, the diameter, and the curve gamma. Now minus r to plus r is nothing but on the real axis, so that's why it's function of x, whereas this gamma part both real and imaginary, that's why function of z. Now integral over c f of z is equal to what? Minus r to plus r f of x dx plus integral over gamma f of z dz. Now by Cauchy's lemma, actually this is not in our syllabus, just you write this line, this is enough. By Cauchy's lemma, when r tends to infinity, this r tends to infinity, this part entirely becomes 0. When r tends to infinity, the curve gamma f of z dz tends to 0. It's one of the important lemma. with help of this only you are going to prove integral over c f of z dz, which is equal to the given question. Hence integral over c f of z dz, which is equal to minus infinity plus infinity f of x dx, is nothing but given question. So instead of evaluating this integral, it is enough to evaluate integral over c f of z dz. You know what is this? It's nothing but Cauchy's residue theorem. If I apply Cauchy residue theorem for this, that gives you a required answer. Now we'll move to what is third type. Type 3. Again, type 3 also, C is the same. In type 3 also, C is simple closed curve, consists of the real part, real axis minus r2 plus r, and upper half of the semicircle comma modulus of z equal to capital R. So in type 2 and type 3, your C is nothing but this semicircle. It consists of two part, this arc gamma and the real axis minus r2 plus r. What is the new in type 3? The main difference between type 2 and type 3 is the same limit is same, minus infinity plus infinity, that rational function p of x, q of x, up to the same. Additionally, we have one more term, cos mx or sin mx. It is not compulsory you must get cos mx, sin mx. It may be cos ax or cos bx, or in numbers also. Okay. Now again the conditions are same, p of x, q of x, degree of q of x greater than degree of p of x at least by 2. That condition and all remains same. So after this, what we did in type 2, the same we're going to apply in type 3 also. Only the new step is in product we have cos mx or sin mx. You need to rewrite this in the form of exponential, that I will explain you while solving problem. Yeah, it's already is there. Look this integral over c f of z into e power im z dz. So the given question, rewrite this form, integral over c f of z e power im z dz. What is e power im z? Is nothing but cos mz plus I sin mz. If your question contains cos, means take real part of this. If your question contains sin, means take imaginary part of this. But while solving problem, you are going to take e power imz, either sin or cos. You must take e power imz. Depends on the given question. In final answer, you must take either real part or imaginary part. Now concepts over, we'll move on to problems. So I hope everyone understand what is type 1, 2, 3. If you not understand, please repeat this video once again. Thank you.